Hello, welcome back, Jayaraman sir. I request Jayaraman sir to start the session. Jayaraman sir. Hello, am I audible?
Hello, welcome back. This is Jayaraman here.
Welcome back, sir. Thank you, sir. Please start the session, sir.
Start the session. Okay, thank you so much.
Yes, sir. Yes, sir.
Welcome back to everybody. Hope you had a good tea or good breakfast. Is it visible now, Rambabu Garu?
Yes, sir. It's visible, sir.
Okay, we are ready. Today, I'll a little bit talk about the industry requirements and then go further into my session like automation. Okay. I'm going to talk till 1 o'clock or 1 p.m. as they call, and hopefully you will all find it interesting. Okay. And I thank the college or institution for having provided me the opportunity to talk in this particular STTP actually. Okay. Today, what we are looking for, the industry, I am representing industry and academia at the same time. Sometimes I will say we means industry, sometimes we means faculty or academia. So I will change it actually. Okay. Today, industry strengths, high performance, that's all. We want the best. Okay. It should consume low power. It should have no tethered connection, no tethering. Everything should be untethered or what do we call wireless. Okay. These are all the major things. Another one, more portable, more wearable, more powerful, and for ubiquitous and pervasive computing. That's all what is required. Okay. It should be available everywhere and it should be available. You should be able to go inside and talk to various things. This is actually how the start of IoT came up, and I'm going to talk about IoT towards the end of this particular session, somewhere when you really start getting hungry, okay, that is 12:30, 12:45, I'll start doing. Have something to munch so that you will be able to listen peacefully lecture. See, if you really look at it, there are various, these are all the industries which can accommodate every engineer of yours. That means what? Today, if you produce a competent engineer in any discipline, whether it is mechanical, civil, or ECE, whether he knows wireless, whether he knows embedded system, whether he knows sensor and sensor conditioning, so he will get employed. There's no question of himself not getting employed. It's a question of only understand it actually. Just as the industry needs, just as the students need a good job, industry needs competent engineers. Very, very simple. Okay. Engineers or technologists, whatever it is. Okay. So that is actually the underlying thing. So if somebody says, I'm not getting a job, it is only because he is not trying in the right place. Okay. If you are going to be in Guntur and you are going to look for a job in Guntur, probably you have to go to agriculture. If you're going to Tamil Nadu and going to stay in Coimbatore, you will get a job. If you're coming to Bangalore, you will get a good IT job immediately. If you go a little bit deeper, say for instance Pune or Maharashtra, you will get a very good engineering job. There is no dearth of job. If somebody says there is a dearth of job, it is particularly when it is coming to the fresh engineers. The fresh engineers are at a disadvantaged position. Because of the simple reason, the expectation by the industry is little or slightly different from what you are equipped with. So if you can somehow or other meet that particular gap or scale that particular gap or transcend that particular gap, you will get it gainfully employed, and there is no problem with it. See, look at it. Pharmaceutical industry is growing. The space research is growing. The defense and defense production and defense R&D is growing. The toys and the consumer items are growing. And people are moving away from Chinese good. Of course, Taiwan will be still a challenge. But these are all the things, opportunities that everybody should exploit. Okay. Same thing in a different way. I'm just giving. Okay. Now, this is what I'm going to talk about it now. Just 1 minute. Let me switch on. Let me see whether I have switched. Oh, you, so many things I have opened, I say. By mistake, I think. I don't know what is the problem. I am trying to switch on my camera. I'm not able to see where it is. Okay, don't bother. It's not a very great attraction. So that is actually the first discussion. So automation. Okay, I'm just going to cover this automation in this following way. Okay. First, why we need automation at all? Okay. And what is the relevance of automation in this present industrial scenario? Okay. And what is automation? How automation is achieved? And obviously, we have to talk something about GST platform. Just as a Kannada movie or a Telugu movie or a Tamil movie or a Hindi movie, suppose I saw a movie called Andha Kanun, Amitabh Bachchan. Okay. At the end of somehow that Andha Kanun name should come. So similarly, since this is actually STTP using actually graphical system design or LabVIEW, so I have put the LabVIEW introduction to GST and automation engineering. So I have put that also. In the last day, I'll put the same thing in communication. That's all it is. So there are three things. One is embedded solutions, centralized and distributed automation, and third one is IIoT, and one healthcare industry I've taken because healthcare is going to grow in our country because of the growth which our Prime Minister or the people in the ministry are trying to put it onto. Okay. This slide you see. Okay. This is what we teach in 8th semester. 8th semester, all these things are taught. Okay. Mathematics and some civics and independence or Constitution of India is beyond this. Okay. Though that is not there, but technologically only these things we are talking about. See, plant or process, that's where we start there. That means what? A wireless communication system or a typical control system based application. Okay, that is actually the plant as well. Say for instance, a DC motor is a plant. Okay, is a man. A telecommunication telecommunication system is a plant. Okay, this plant has got certain process variables. Suppose you are talking about a wireless communication system or a radio system, radar system, whatever name you want to give it. Okay, it is actually transmitting certain data, certain signal, and receiving certain signal. Based on that, you can find out whether it is a target or simply ground. Okay, so this particular thing probably will have certain process variable. What could be the process variable? Probably signal to noise ratio. Okay, in an analog system. In a digital system, it can be bit error rate. Something like that. Okay. Now, this has to be captured, or it can be actually a simple thing like a signal, transmitter signal, receiver signal, all those things. Okay. Now, this has to be converted or power factor, or actually the current, or energy, voltage. You say whatever you want to do. That is actually what is there. Then it has to be transductor. See, in a typical thing, I will not use sensor because everything is not sensor. Sensor and transducers are different. I'm using transducer, which is much more broadly used for such things. Okay. So transducer, what is the job of the transducer? Transducer is supposed to convert a physical variable into an electrical variable. That's all the job. Okay, that's all the job. Now, this transducer voltage, you take a biomedical signal from your body, and that signal has to be transducted by one transducer. Whatever pressure transducer you take actually as what we call strain gauge as a sensor. So anything you can put it actually, and our temperature thermocouple as a sensor, you take it actually, you will get the physical variable, that is temperature read in some degree centigrade, etc. Now what you have to do, you have to convert that into an electrical variable. Why you have to convert into electrical variable? You have to convert that into an electrical variable because you have to process that signal using electronics or electrical system. Okay, so the transducer is meant for that. The transducer is basically meant to convert a physical variable into an electrical variable. That means from a velocity, strain, vision, acceleration, or vacuum, I am going to convert it into is current or resistance or voltage. That's actually. Then what I do what is known as single condition. The people in the electronics and communication or electrical disciplines, they should know what is the difference between a simple amplifier and a signal conditioner. They should know. Those people who don't know, then go to the www.ni.com/signal conditioner tutorial and you will get all the information. I have read it, so you can also read it, probably understand it better also. Okay. What the signal conditioner does is actually, it does signal amplification. It does reduction of noise. It does isolation. It generates an excitation voltage. If it is a bridge configuration, it needs excitation voltage that is being given. So that is actually the job of a typical signal conditioner. Then what is the next one? So I will come to this particular place. I have a processor or a controller, and that has got interface to the real world. This is the real world, and it has got a I/O peripherals. All those things are there. Okay, so this processor needs to be programmed. Okay, now so I need a programming interface. So what is the application program I have to write here? Acquire, analyze, display, present, communicate, control. These are all the various types of actually possibility exist. Okay, and I need a programming interface. What is a programming interface? Probably C compiler, probably C cross assembler, probably LabVIEW interpreter. Okay, or C basic interpreter, or assembly language programming, some interpreter, etc. is required, and the programming interface depends upon the language which you are using. Suppose I say use LabVIEW, then you need a LabVIEW environment. That's actually the one, because it's a LabVIEW session, so I'm putting LabVIEW, and so this is what is the basic thing. Okay, now the system, the process can be telecommunication system, it can be a transportation system, it can be aerospace system, it can be a defense system, it can be healthcare, it can be a consumer, it can be entertainment. Okay, it can be anything, and this is actually the path. That is, you try to take a signal out of the process plant as it is functioning or working, and that particular signal should be given to a computer or microprocessor based system or microcontroller based system or processor based system, whatever name you want to give it, you give it, and that should be, you have to write a software. The software is acquire, analyze or process, whatever you are comfortable, and it can be present, it can be display, or it can be communicated to a remote or to somebody, so to a user actually. And then if it is required, you have to generate a control signal and apply to the plant. This is actually what I'm thinking. All these things are taught in 8 semesters. 8 semesters, this is what we are teaching. Okay, there is nothing else we are teaching. This is what. Okay. Same thing I would have written in so many. See, today programming languages, I have, this is actually the last slide of this particular group. Assembly, VHDL, C, C++, Java, Python, LabVIEW. Okay, I have put LabVIEW, but when I actually go for the LabVIEW people, I'll put LabVIEW first. Now, I have divided this particular microprocessor or microcontroller based system into 4 blocks. The processing element, which consists of CPU, processing element of the CPU. Second one is actually timer. The third one is the memory. These 3 are core. Okay. Then I have a real world interface. What is the real world interface? If any one of you can remember or recall your 8085 kit, it is 8255 or something, 8251, 8255, 8155, those type of things. And you have a communication interface. It's basically USART or UART or USB or Wi-Fi, whatever it is. And you have a user-based user and debug interface, which is basically a display or a switch or what we call actually a debug, a JTAG and other thing. So if you really look at it, this is the final version of what is known as actually simple system. Okay, a typical plant system or plant system, whatever they want to say. Okay. Now, what is the next one? Next one is actually another beautiful thing in this. This is one concept. Okay. Now, next, I have taken application diversity. This is how automotive was there some time back when Ambassador car, Fiat car, Mark 1, Mark 2, whatever was there, the olden days. Okay, we are only concerned with chassis, audio, engine, safety, electronics, brake, emission, durability. That's all we were concerned. These are all this is a computer, this is a car, and all these things are the only concern we have. Okay, those days. Now what has happened? This has become very complicated. Now look at it. Okay. Global navigation system, audio processing, cellular phone, comfort security, powertrain, anti-lock brace, voice command, electronic steering, you name it, that is there inside. Now, after some more time, it has increased. Look at the type of this one. That means what? A limousine car today has got more electronics than mechanical items. Beauty, you know? That means we'll get a job everywhere. That's how it is. Okay. Every electronic, every automobile manufacturer has some development center in India. You only master one of the aspects of various things that are being talked about. You take any one of them and you will be able to get a beautiful job. There is no second opinion about it. Okay. All the people are looking at automotive as one of the areas. Okay. And this is a further growth. More software, more this one actually. And remote key enabled tire pressure monitoring system, instrument cluster, hands-up display, rear view, adjustment, entertainment, radio head units, navigation, body controls. Look at it. Now, if you really say, Jayaraman, I'm not getting a job, that means you don't know any one of them. At least one of them you should know in your college. That means what? You are the 4th year or the final year as they call, or the last 2 semesters as they 7th and 8th, you should tell the students you do a project. That's all. You may find some students not interested. Give them a dissertation. Okay? Give them a dissertation. Those people who want to do project, you allocate a support or what we call a guide. Don't say that guide, actually it's not it's a mentor. Okay, because a faculty to know everything what is happening current is difficult. So you can have an industry mentor or you can have a local mentor, and that fellow is supposed to monitor whether the fellow is working or not working. That's all it is. Okay, and once you have done that, that fellow will be employable. This is actually the new hybrid technology which is there in that particular thing. Today India is putting a lot of stress on the electric car, and electric car in isolation will not work. So they have put it as hybrid car, and everything is happening. Okay. And these are all the comparison of the LNG vehicles that I'm not bothered. So look at this. This is actually the electronic system level design that one has to produce for automobile system. Okay. This complete thing is supposed to be battery and power management. Suppose you say, Jaraman, I don't like all these microprocessor and all. I want to stay with actually the power electronics. You can do one of them and you are very comfortable. Suppose you say, I want to do embedded processing, then you can go for this. These are all the peripherals. Okay. And you say, no, Jaraman, I am not interested in anything actually. I am interested in the front end. That means what? Analog and probably analog mixed signal design. You stay there. See, the whole idea is a student should be guided or goaded to choose one area. If he says, I'm going to do Android based, or he's going to do Arduino based system and all, the Arduino based system is good for academia, probably a small project. Really professionally, it is not still accepted. Though NI has got some sort of a link or compatibility with Arduino boards, but I don't recommend. If somebody says Arduino board, I don't even interview him, because if he says ARM or ARM9, because I have to be competitive in the industry. So if I'm not going to be competitive, if I'm going to say Arduino, they'll say, oh, it's a hobby project. Okay. Like that they will say. So I don't want to do that. 8051, ARM7, ARM9, ARM11, those are all the things which is supposed to be there. So your students must get into one of these areas and try to become focused, and then do it. Okay. And you will. This is taken from Texas Instrument catalog. A system-based approach is needed to win. See, this whole thing is a system. And these are all various functional blocks that are there. And these functional blocks are derivation of the overall system functionality to individual subsystem functionality. Subsystem functionality is basically converted into component functionality. Component functionality is implemented and slowly backward integration takes place. Finally, you will get a system. Okay. This is actually a typical microcontroller by Texas Instrument again. Okay. Those days I was very comfortable with Texas Instrument because I was getting a lot of documents from Texas Instrument, and I was a fan of that MSP 430, which is supposed to be a low power microcontroller developed by Texas Instrument, and so I continue to get that actually. So see, lockstep CPU with the interrupt controller, interrupt to fault detection. Okay. Lockstep system or fault tolerant computer system that run the same set of operations at the same time in parallel. See, look at it. Actually, you are in an aircraft and you have a microprocessor based system all over the aircraft, and if it is not actually fail safe or fault tolerant, how much you can trust the system? If the captain of the aircraft comes and says, we have an excellent aircraft, sir, come and join, but only thing actually, we don't have a fault tolerant system. If the fault comes, we don't know whether you will fly or you will fall. Okay, will you get into the flight? So in order to provide a fault tolerant system, this person has really created a processor which with the fault stop. Very beautiful architecture. Okay. Now, these are all some of the basic things which are there. Now I'll go to the practice. Now, I do research, I do modeling. Okay, first thing, because I don't know whether the product will work or not. So I model that. Once I model, really speaking, now look at it. You're modeling and I do simulation. So this particular one iteration. That means what? I model, I do simulation, I see whether it is working. If it is not working, I'll go and tamper with the model. Again, I'll do simulation. This particular cycle will keep on going till the model becomes perfect. I know the model is good, proof. Now I will do design. What is design? Actually, it's a very beautiful word, but very, very wrongly understood by most of the people. Design means this is the functionality I want to implement. This is the specification I want to achieve. Okay. And for achieving this, I have a different route of reaching that particular target. If I take one, obviously there will be one small specification which will not be met. That means you don't have a utopian situation where everything will work in the world, all the things. No. 100% perfect system is not a design in the world. Okay. So you have 99, 98, 97 like that only. So in order to do that particular thing, you simulate. Okay. So you simulate. What is simulation? Let us take a simple thing. That means what? You have an amplifier. I'm taking amplifier because most of the people know amplifier. Okay. So amplifier, in this amplifier, so I model the amplifier. I use SPICE model, or if you really look at it, actually our multi-sim or something like that is available in LabVIEW. So use that actually. So you have a multi-sim. Okay, I have simulated. What is the simulation means? Assuming that I'm a 75-year-old fellow, I have a bell or clock which gives you a very sound, very loud bell. That bell is supposed to wake me up at regular intervals. At 12 o'clock, again I am awake and I'm going to stop. So simulation. In the simulation, what I do, I take one resistor. Let us take our simple resistor, one 10K resistor. So 10K resistor is never, all the 10K resistors are not 10K resistors. It will have either 10.1K or it can be 9.9K. That means what? Your design assumes a typical figure of 10K, but if it goes below or if it goes above, you don't know whether it will work or not. The previous years, we used to actually connect it and then see whether it will work or not. Okay. But we take some 10K resistor, put one by one, everything is working, okay, take it. That's all it is. Now you can simulate it. So I put that resistor slowly below 9.2. Okay. I try to take it there, 10.4. And I simulate that particular amplifier, whether the gain is achieved, whether the bandwidth is achieved, etc. Then only my model becomes. I model, I simulate, I change the model, simulate, change the model, simulate. Like that I will do it. I perfect the model. Now it goes for design. So I have designed, I have taken an op-amp, I have put some resistors, I put some capacitors, everything is there. Now verification and validation comes. So we teach this in VLSI. How many of you really know what is verification, what is validation? What is the input one should take for verification? What is the input one should take for validation? We don't know. Let me say. What is verification? Okay. Verification is product right, RIGHT. Validation is RIGHT, right product. That's all. 2 words. Product right, right product. Now we'll go to the basic thing. The user gives his requirement. The system development develops the specification. The person who is doing actually design divides that particular architecture into creates an architecture. What we call actually the modules. He creates various modules and given to various people. That means system specification is converted to module specification. Module specification is given to a developer, and he develops it and checks or verifies against the module specification. Verifies against module specification. Now module is perfect. Okay. Now I have all the modules. I integrate it, and again system specification is met. It's beautiful. But I don't know whether it will meet the user's requirement. So I go through a validation. Validation process is against user requirement. I validate the product and then finally say, yeah, this is the product you take. This is the specification you make, and you are okay. Because a person who gives the requirement doesn't understand the ICs or operational amplifiers or even actually concrete or anything like that. He gives, I want an elevator which should reach 25th floor in 1.5 seconds. That's all. He gives one specification, and it's up to you to find out what type of control system, what type of controller, what type of pulley system, what type of what we call bearings, whatever you want to take it, actually you should do it. That's actually the verification. Then of course it goes to manufacturing. It's all that. So what is our requirement? In the present context, I have one particular platform for doing this, one platform for doing this, one platform for doing this, one platform or one language for this. That means what? In 4 levels, I have different platforms or different what we call actually different software or hardware, and a person has to learn all these things. That means I cannot put a fellow who is doing the design into manufacturing specification. Oh, I cannot put it because he has to learn another tool, another platform. Now, if you use our lab, you have to, it's a common platform. It will start from modeling till manufacturing product is out. You have only one platform. That's all. So you don't have to really break your head to learn 100 platforms. C, assembly, prototyping, everything is covered in one platform. That's the beauty of this, and you should realize it. Okay. Now I was been talking about the systems approach to solutions engineering or system level design, all those things. Okay. Now a person wants something. He defines his specific. He defines what he wants. Please don't think that he is already decided whether he is going to use ARM controller or microprocessor, or actually say for instance Pentium or the RISC or anything like that. He has not decided. He will say, what are all the inputs I should use? These are all the inputs. This system should work, and then gives you this output. That's the first thing the system designer should get it. Now he keeps on doing it, and then system. Now next question you have to ask this fellow, hey, this system I'll design it because it takes some input, processes, and gives you some output. Now what is the next thing you have to ask him? Hey, where are you going to use the system? Is it going to be in your house, or is it going to be outside on the tarmac, or is it going to be inside a burner or a pressure cooker, or it is going to be an aircraft, or it is going to be a military vehicle, or is it going to be in a, say for instance, in a tank, or a tank means I meant war tanks, not water tanks, tank, or in a washing machine, or in a toy, entertainment system, toy. So once he knows, then what does he get? He gets the environment in which it is going to work. He gets the environment. Now he has got the environment. So the environment, then he is supposed to deduce what are all the various external variables is going to affect the system. Suppose I have actually, say for instance, in a washing machine, I'm going to make some controller there and put it there. And that particular thing positively will face shock, vibration, and probably the heat, probably the water flashing, all those things. Those are all external variables. So external variables have come. If I'm going to design this particular system with all external variable, meeting all the external variable, that's a great system. You cannot meet. It is not, it's a utopian way. So what do? I take some of the most critical external variable and take it as a constraint and start designing. Then what I am doing is actually, before designing, what should I do? I should arrive at what functionalities this will meet. So functionalities meet. Now what is the next thing I have to do it? See, today, in today's context, I can develop these functionalities either in hardware or in software or in using a switch or a knob. Okay, or that we call as humanware. Okay, humanware. That means what? The functionality need not be all in software, all in hardware. It depends upon the external variables or the user requirements. You are supposed to allocate the functionality to different hardware or the software or humanware. That's all. Okay. So now I have done it. That means what? You integrate. That's all. You integrate. This all. There's nothing else. Now, what is the problem? Now, today I am not very good in software. I don't know how to optimize. So I will make everything in hardware. Okay, I will make everything in hardware. Now, over a period of time, probably I have become proficient in, say for instance, Python. Then what I will do, I will take some of the functionalities and put it in software. Now, in VLSI, there is a concept called hardware software co-design. Okay, hardware software partitioning. These are all concepts which is there. Now, how much you should do in hardware, how much you should do in software depends upon the requirements of a user. Suppose I want actually a very, very adaptable system which I can change anything in life. I will go for a software-based thing because software can be managed by reconfiguring it. If I am putting in hardware, if I have to change, I have to go for a hardware change, which is very difficult. That means I have to develop a new PCB, not possible. So it's a question of only the choice by the user. Suppose you say, Jayaraman, you design this particular system. Okay, you design this particular system. I used to be not very conversant with software because those days microprocessor was not there, and we learned Fortran or COBOL or some funny language, and it was all used for business oriented only. So I will do only with hardware. Because my knowledge of the hardware is as good as good. Okay, as good as good. Microprocessor came, then some of the functionalities I put it into software. My hardware is low. Now go further. As the days go by, this hardware is shrinking in size. Our software is growing. This is what happening to your computer. You open your mobile and you will see that actually your mobile is full of software. And there is no. That is because you have an operating system. You have a DLL or whatever it is. And on that particular thing, they will hook is application software, put it together. Whenever you want to use the software, use it. Whenever you don't want, allow it to be demoted. That means what? You can control the power consumption also. So if you really look at it, actually, your student must be able to develop everything and make the prototype ready. Then you should say, oh, I have to reduce the power. Huh? Okay, let me see whether I can move some of the functionalities from hardware to software. Then I can reduce. So these are all something imagination that fellow should get in. Then only he will become an engineer. Otherwise, he will become a degree holder. That's all. Okay. Now this is actually another one. Now before going to this, what is the major problem with the real time? Okay, real time. I want to define it. I will define it. See, in a typical system, I showed you the full thing: plant, process variable, transducers and microcontroller, everything I showed you. Okay, now I have three partitioning. This is a cluster. Cluster is the fastest processing thing, and now peripheral. This is actually little slow, but not as fast as this. Okay, slow. And now we have a sensor actuator which is as good as 1 millisecond. It will change over. If you take a thermocouple, in 1 minute, it will change the temperature. Okay. So this is a very slow thing. That means what? If you are going to do a real-time computer, actually, I will define a real-time down the line. And real-time computer, you have to bring some sort of a coherence between the three timing areas. Okay. Fastest, little fast, and slow. These are all the things. That is a major problem which a student is not able to understand, because students just never measure the time it takes for a microprocessor to work. Hardly any student I ask him, what is the execution time? They don't know. Program line, say for instance, program execution time, they don't know. That's the problem actually, because they have never measured. If you really look at it actually, what is the consumption of a typical amplifier? And they don't know, because they have never measured the current of a typical. They know voltage is 5 volts, okay, or 3.5 volts. They don't know the current. So how can they make a power efficient microcontroller based system for me? They cannot. So I have to teach him low power application, low power systems. Product design process. This is more of a V diagram, which we say. Now I will just tell you one aspect of it, because you will see a lot of this one actually. In the olden days, system definition to system testing and making the system available used to be very large, as good as 6 years, 10 years, 12 years, etc. Okay. Now the system definition time is shrinking. That means if I release one version of a car, automobile, I should get that within 6 months or anything. So after 6 months, again, another system will be defined. That means what? Your rollout or your ability to stand in that particular thing, V diagram is one thing. This particular thing is shrinking, and once it is shrinking, your student must be really fast. They cannot take 2 years for doing one project. No. They have to do it in 2 hours. 2 hours, one amplifier should be designed and thrown out. Then they should say what is the manufacturer. All those things actually. And these are all some of the variants of that. Now, since I'm going to talk about an automation, there are some faculty or there are some students whom I have provided. Sir, tell me what they are looking for as in an automation engineer. This is actually a requirement. I pulled it out of some advertisement and put it here. Okay, that's all. My job is only to copy paste. Okay, in this because I don't know. See, yeah, automation engineer can be a process control engineer, can be a process control system, or what is it called? Some knowledge of instrumentation control application, field instrumentation, safety system, process hazard analysis session, alarm objective analysis, safety objective analysis. Look at it. Ability to perform alarm management assessment and lead remedial of issues. Oh God. Instrumentation and control technologies determine. And many of the people from electronics and communication engineering has told me, sir, we are all electronics and communication. So why should we do instrumentation and automation? Please understand, this electronic instrumentation control system is all only for some namke vaste. College has got a permission to have electronics and communication, 120 students. So they have put this. But you are basically an engineer. Engineer is to create something. You don't have to, it is all multidiscipline, interdiscipline, and various things, solutions you have to bring it. You see, for instance, I have studied thermal electronics for more than 2 years. There is 2 semesters I have studied because I need that. That's how it is actually. By basically a transistor, when it is operating in a power supply, you have to reduce the power consumption. You have to throw away all the wasteful heat which are being produced. And that's not possible if you don't understand the conductivity or radiation or actually conduction, radiation. This is what we have learned in 8th standard. Now in engineering, we know how to do that actually. Okay. And distributed control system is one of them. Program-embedded logic controller is another one. Understanding field instrumentation, like this one is a instrumentation. Actually, an electronics and today everything is communication. I'm going to talk about IoT. You will see communication, how it is proliferating in the industry. And what is basically problem? Problem is, don't get yourself isolated from a typical requirement. It's all what is there actually. You need a microprocessor based system. You have studied, a student has studied. You need a signal conditioner. You have studied analog and digital electronics, A to D converter, etc. You need to write the software. You have written. What you don't know is only the, what is it called? The sensor. Sensor is a bought out item. You buy it out. Whatever is the thing, you should know how to choose a sensor. What is the next one you don't know? Probably you don't know control system. Probably in some of the colleges, control system is taught to electronics and communication engineer also. Control system. That's all. So you know everything, but only because it's called automation system in electronics and instrumentation system. Sir, we don't know. We are ECE people, sir. ECE people think that they are one of those great fellows. No. They are the worst fellows because they are neither Nagarka, Gatka, that type of thing. You don't know where. I will take an instrumentation engineer and make him control system engineer. Why should I take an electronics and communication engineering? Anyhow, ECE people will try to go abroad or do anything like that. So why should I take that fellow? This is actually the attitude against the instrumentation, ECE people in the marketplace. I'm just telling you, please tell that. So why automation? Productivity, cost of the product, volume, repeatability, reduce manual intervention, etc. What is automation? Now, I put it in one simple thing. Acquire, measure and understand. Measure, understand. Then that is actually a measure, understand, comprehend. Analyze. What is the solution? Display, communicate, control. That's all. Either one of them or all of them. See, in communication, I'm talking about, say for instance, remote control, okay, SCADA, supervisory control and data acquisition system, or satellites to be telemedicine. These are all communication. Okay. Control is actually, it can be a centralized control or distributed control. You can have. And this is actually display. So a manual intervention is required, and that is actually given by a display. Okay. Display is also there. So anybody who asks you automation, acquire, analyze, control, display, or display or communicate. That's all it is. So I come back to this. Here I'm going to define what is an embedded system. Okay, what is an embedded system? Many people have come out with many definitions in the world. Okay, it's a software designed meant to for this one, etc., etc. It's all there actually. It's a lot of definitions are there. I'm going to give you my definitions. Okay, it's not there in textbook, but over a period of time, purely by my own experience in the embedded system, I have given a definition. That means what? What is our interest? Our interest is this process variable which we are bothered about controlling it. This process variable tend to change or likely to change. Okay, likely to alter because of so many reasons. Okay, mainly environment. Okay, and this particular process variable changes. What is the control system doing? The change or deviated process variable is brought back to its normal condition by all the system. This major thing is this. This is what is doing it. Okay, and the software. Now you take one more step. This is actually the automation system is basically is a possibility of the process variable deviating. You measure, analyze, and develop a control system to bring back the deviated variable to their normal operating condition. Finished. That's all it is. There is no, you don't have to bother about anything. Okay. Now go one more step. What is the step which you are talking about? In this step, actually, I'm going to define embedded system. Now, take all these things. These are all something which you are comfortable, and put it inside the plant itself. That means the acquire, analyze, control is inside the plant now. Okay. The plant is actually what it is supposed to do. It is supposed to deviated variable. It should mind out and it should control that in the all within that. Actually, all within that. Okay. Now, suppose I am the person. I am 75 years old. I keep on telling you. Of course, for Rohit, it is 78. Don't bother about it. 75, 78, 70, all those people are there. What is the problem which we will face? Normally, the sugar level will go up. We are calling diabetics. Okay, some funny name we are given, diabetics. Okay, sugar level in glucose level, whatever name you want, you are comfortable, will go up. Suppose I design an embedded system, put it inside my body or inside, wrap it around my hand. Okay, and this particular, what is it supposed to do? It is supposed to take a sample of a blood, acquire, okay, a sample of blood, analyze, find out whether it is more or less of the standard value. If it is less, don't bother. If it is more, what do? You try to take one insulin dose, whatever the dose, and inject it in the blood. All these things are happening as I am delivering the lecture within my body. You understood? Yeah. Now I'll give a definition, which is supposed to be proper. Embedded system is an electronic controller. First thing, this is electronic controller according to me. According to me, I think you can also define. Okay, built into the application, that is, put it inside this plant. Continuously monitoring the process variable. This process variable will go there, and ensure that the process variables will not deviate. That's all. That's the job of the embedded system. That's the automation. Now, if there is a likelihood of a change, in the unlikely event of a deviation, what it will do? This particular controller, embedded controller, will generate a counteracting signal, which is a control signal, and apply to the plant to bring back the deviated variable to their normal operating condition. Finished here. Embedded system. Many people are making the thing. What is the thing? You need a microprocessor, a microcontroller based system. You need the software to be written on that. You need that to be put into a typical environment, which is a plant, and ensure that is working. That means an electronic controller built into the application, continuously monitoring the process variables and ensure that the process variables do not deviate is embedded system, embedded solutions, whatever name you want to have it. So this is everywhere embedded system. That means what? If your students are very comfortable in embedded system, if he doesn't get a job, that is his own probably karma. That's all. Because embedded system, I know only embedded system. I don't know anything else. Okay. I knew it as logic control. Now I know everybody calls it embedded system. I'm also calling embedded system. I can get employed continuously. I'm telling you. That's a very great thing. Any application you give me, I'll create an embedded system. I need a good software guy because I'm not a very comfortable software person. So I will take a CLAD certified LabVIEW person, or what is it called? Python based one software, and I will get that embedded system operational. I will get the embedded system operational very, very soon. I'm very comfortable. This is what it is. See, look at it. I have actually, this is actually a conveyor belt. Almost everything, manufacturing is growing in our country. So conveyor belt is there. So if you are going to be a vaccine supplier for the whole world, obviously you cannot run it with one fellow carrying vaccine up and down and trying to get all the things. It has to be conveyorized. And our Hyderabad person has done very well. Dr. Krishna has done very well. And I'm sure there are lots of plants coming up in Gujarat and in Bangalore, in Hyderabad, and we are going to be one of the global supplier of medicines and vaccines, okay, and intermediaries, okay. We are going to be, okay, at least for the this not developed, less developed countries, okay. So you look at it. This is for a PCB assembly machine, and I have an operator interface. I have a motion control, which is basically vision and motion. Vision is somewhere here. Okay, motion control, and discrete control is on off. And you have actually the machine control, machine vision, which is basically a camera-based image processing software. If you are very comfortable with that particular book of image processing, you can do it. And you have a temperature control, basically it's there. And you have this whole thing operation. That means what? Automation. That's all it is. Okay. Different controllers for different applications. You don't have one controller. You have one type here, one type here, one type here, one type here, one type in the this one. Different networks and operator interface. That's also there. Communication. Embedded hardware component. The COTS is actually commercially off the shelf. Okay, closed software which is supposed to be working only for this. And you have a supervisory control and data acquisition system, which is what is being done by the main operator console. Okay. So how to automate? Measurement automation, process automation, industrial automation, office automation, factory automation. Actually, I went through some of the things, actually. Automation, all these things came. So I thought I'll put it in the slide and tell you that automation doesn't mean only the industry automation. It can be an office automation. Nowadays, actually, even the residence can be an automation. Hospital can be automated. Anything can be automated. Okay. Now, the implementation can be PC-based automation, embedded automation, centralized automation with all the people giving. This is SCADA basically, and distributed automation is DCS, and that is supposed to be IoT based. IoT based also is there, and NI LabVIEW, NI platform has got a lot of variants available. I'm going to show some of them. I don't say all those things. So manufacturing, machine control, control system, flight control, engine control, motion control, energy, everywhere this control application there. Okay. It's a beautiful thing. Okay. These are all technology trends, which is actually being practiced. And you look at it actually as a communication person, look at it. Ethernet, USB, and 1394. Suppose I tell you, hey, you develop a 1394 or USB based networking business for me, networking controller for me, how many of your engineers do you think will be able to do that? Or if I were to say an NFC controller or near field communication controller as a wireless system, how many people can do it for you? Okay, so your whole concept should move from teaching what is there in the textbook. Really speaking, many of the people who are not interested in attending the classes, it's not because of anything. We are teaching what is in the textbook. We are teaching what is in the textbook. You go beyond the textbook, and You say at least initially you say about 40 minutes I will teach what is actually the theory as per the syllabus, and 20 minutes I'm going to put it as a project or a particular development and latest, and that is what it is. Actually, it is going to be a very big challenge for many of the faculty to get into it. Okay. Multifunction controller. This is another thing which is coming up. I showed you one actually from Texas Instrument. Yeah, actually you go to any company which is manufacturing chips, they are all having actually the controllers and everything. Common development tool. This is what they are looking for, but I think this has not been achieved yet. So Xilinx has got its own controller, its own development tools. If you go to Altera, it has got its own development tools. So development tools are actually different. People have got different. And nowadays, actually, fixed point to floating point to get the better accuracy, better repeatability, they have moved this to the floating point. Okay. So modeling, prototyping, characterization, analysis. This is the core essence of LabVIEW, and probably it's actually the engineering. Okay. So I have made actually, these are all I'm going to run fast because I'm going to spend enough time there, and it is 12:30. I have main topic is coming up. Okay. And the software defined instrumentation. See, all of you would have heard about software defined radio, software defined networking, and I am giving you software defined instrumentation. Previously, I used to call it as virtual instrumentation. I don't like it. Okay. It is software defined. Instrumentation is the same. There's no virtual. And actually, according to me, those days, I will say virtual instrument is a real instrument where instrument functionality is defined by the software, not by the hardware. That's all it is. Okay. And that is actually. So we have various types of process control. These are all some of the techniques which are there. Actually, most of the LabVIEW has got all these things today. That means what? If you really get into the LabVIEW in a big way, you will be able to do any project in anything within a short time. Actually, the ability to build an application or a prototype within short time is actually LabVIEW, because the proof of concept can be more or less done. See, for instance, I took a project some time back, embedded system. I used MyRio, which is actually a LabVIEW NI product. I used LabVIEW as for the programming. I could do a 3-axis control with because it has got a built-in sensor. I don't have to put any money extra, and I have the whole thing operational within 3 days. That is 72 hours, out of which I worked for only 30 hours. Okay, I worked only for 30 hours. Okay, that's all it is. It's possible. So try to adapt. I don't say use LabVIEW only. You can use Python, you can use anything else, but you start the proof of concept with the LabVIEW. You have the user interface very clear, and you have a block diagram which is very clear, and you will be able to do it better. Okay. This is what I wanted to say. Motion control. This is okay. MyRio is what I am suggesting, recommending to the colleges or institutions. Of course, they have compact Rio. What I showed the initially, compact Rio is available, and they have actually the SB Rio, which is, I don't know whether still it is in the marketplace. Single board Rio. Rio means reconfigurable I/O. Okay. Student embedded device. This is what is. This is a MyRio. I'm not going to break my head with that. This is actually other Rio, single board Rio, flex Rio, compact Rio, R series, FPGA board. Everything is FPGA because of the simple reason. It's a FPGA is a parallel processing, and if you really look at LabVIEW is also parallel processing. Okay, so if you are going to have a parallel processing hardware and on which you are going to run a parallel processing software, you know the amount of software, the speed up what you will get. You will not get in a typical text-based program or in a typical microcontroller. That's how most of the people are moving to FPGA, and of course, NI is full of FPGA only. Okay, the programming. I'm not going to break my head. Okay, this is something which I'm just telling you for academic sake, nothing beyond that actually. And LabVIEW has got one thing called programmable automation control, which is basically a distributed control, which is SCADA based or distributed control system. And you have the controller two types. One is actually PLC. Okay, PLC is extremely reliable, but really speaking, the functionality it's not that good because it's not hand carved. So it's something like a ready-made shirt as far as I am concerned. Okay, built actually. So whatever it is, you adjust it within yourself. The other one is actually the PC. That means you make a 8051 or ARM-based controller. You can hand carve this what is known as actually the functionalities. So it will be really good. There's a gap. In that gap, so they brought it actually what is known as actually the gap is filled by the PAC. The PAC is supposed to have the capabilities of a PLC. That means rugged. And it has the capability of the PC, not the personal computer. What's it called? It's a 8051 based programmable controller. Okay. Applications, applications are so many. Okay. This is compact trio is very rugged. Suppose you want to do for automobile, etc., you cannot manage with a commercial hardware, so you need to go for a rugged hardware, and the rugged hardware is provided by NI compact trio. Okay, that's all. Actually, this is not. I'm not going to break my head on that. There is a lot of people who are going to talk about it. And only thing good about adapting or getting into the NI-based system development is actually NI platform-based system development. NI is continuously researching, and they are coming out with the more and more comprehensive solution. LabVIEW is actually, I started with 5 or 6 actually. Now it's like somewhere near 14 or something like that. LabVIEW next generation is also coming up. So you have a lot of LabVIEW functionalities built in now. So it's better to go with a company which is continuously evolving, so that your solution also will be more and more comprehensive, more and more good actually. That's actually the way. Okay. IoT, this is the last portion I'm going to do it. I have taken healthcare. Okay, healthcare, because I have found that actually, many of the actually recent magazine on Week actually they say that India is becoming a global leader, particularly for the developing countries of medicine or healthcare. Okay, I'm not talking about people visiting us. I'm talking about actually the medicine supply, or actually the vaccine supply, or ventilator supply. All these things are going to be from India. So India is going to be very great. And IoT is going to be a very big thing for healthcare industry, particularly hospital-based or the industry-based commercial thing. Okay. IoT is what? Internet of Things. That means what? All around you have things. And all these things have got process variable. And if you can take all these process variables of the things or objects and make the objects to talk to each other without yourself getting into the conversation, you have a best blissful life. You can sit and relax. Somebody knocks the door automatically opens. So as soon as that fellow comes, that the voice annunciation system says, Mr. Source Jayaraman has come. Okay, and the owner can take a decision whether to sit in the sofa or sit in the chair, depending upon the hierarchy which he is going to give, and then start talking. Once he talks, actually, probably the air may not be enough. So switch on, automatically the fan will switch on. And suppose you are sitting in the dark, they will not switch on the light. They will try to, that is the objects will try to move the curtain slightly upwards so that you get enough this one. If there is an external noise, automatically the doors, that is the window, will close it. So all these things are actually IoT. So they have done is actually Internet of Healthcare Things. That's how they have put it. And HT has come. IoT or IoT, IIoT also there are people. So now I have come to this is the first slide, and this is what everybody should understand it actually. So you have these particular requirements. What do you require? You need a smart parking. You need smart energy. You need smart home. You need smart grid. Just as you need a smart daughter or a smart wife or a smart husband or a smart children or smart parents, etc. As the days go by, you look at actually everything smart. Smart lighting, smart cars, smart tag, smart health. So everything they want smart. That's all application. Today people are. So in order to create that, what do you require? You probably require a technology of three things. One is actually sensing. Second one is processing, embedded processing. Third one is the connectivity. That's all. You need this. Because I know a little bit more about it now, because I'm trying to develop a practical desk-based desk system for the faculty or for the colleges or institutions to learn IoT thoroughly. That means what? Your students, all the people, IoT is a common. It is like having a rice. Whether you want to make what we call Hyderabad biryani or Ambur biryani, I'm a vegetarian. Please don't think that this fellow is eaten everything and talking about it. No, I don't eat. Okay, Ambur biryani or actually some other chicken biryani or actually vegetable biryani, basic ingredient is rice. Okay, so what do? You try to develop that particular ingredient. I'm supplying to you. Okay, I'm supplying to you. Now your student can say, sir, I want to do something IoT for healthcare. I want to do a IoT for, say for instance, agriculture. I want to do IoT for what is it called, mall. I want to do IoT for home, big homes. I want to do IoT for even college lab sessions or this one. Everything can be an IoT. So what is the basic thing? He requires all these functional blocks. What is the functional blocks? He needs a sensor. He needs sensing system. He needs an embedded processing. He needs a connectivity. So once he has got, he has to understand. So what is the basic? Jaraman, you say so many things. How that fellow will know mall? Oh, send that fellow to my house. I will teach them how to analyze a mall. How to analyze. Let him go to 3 malls and find out where all it can be applied. Talk to the mall owner or mall caretaker. Then let us do it. See, nothing will come to your house. Nothing will come to your college. You have to go there. So it's a beautiful, no? Today, actually, every engineer can be employed, I say. Every engineer can be employed. I don't know whether you are. Actually, this has been, I can only talk about Chandrababu Naidu, because I know only I was dealing with him. And probably Y.S. Rajashekhar Reddy also must be doing the same thing. And of course, Chandrasekhar Rao. All these people are trying to develop a full-fledged IoT for the whole state. IoT is growing in a big way in Karnataka. Okay. So IoT, everybody is talking IoT because it has got a multiple technologies and everything is coming together for giving one application, many applications, etc. Today, healthcare industry and smart lighting, smart grid, if you can really develop that, nothing like it, energy consumption can be off. Already, Modi ji and his team is looking at actually electric cars so that the diesel consumption is going to be reduced. You go further and optimize the energy. Okay, that's actually the way in which I want you to look at it. There's a software, and the fellow should write the software in Python. Okay, and you can use C, you can use assembly, you can do assembly. So you can do healthcare. I just want to tell something about the healthcare. Please don't think that it's out of syllabus. So I just want to tell this. The way I'm saying about it, actually, you are teaching your students, and you should know a little bit about those technologies. Okay, those technologies, because without that, you may not be able to do justice to that subject. So first one is artificial intelligence. Today, everybody is talking about artificial intelligence, blockchain, voice search, chatbots, virtual reality, advanced social media, personalized mobile application. Okay, and partnership with other popular. This is for marketing healthcare. Okay, marketing healthcare. So tell me fascinating healthcare technology trends for 2021. This is yesterday's thing. Telemedicine, virtual reality, Internet of medical things. We saw health things. Today, people are talking about medical things. Mobile health, healthcare wearable and sensors. Okay, healthcare wearable and sensors. Blockchain, cloud computing, nanotechnologies, 3D printing, big data, and predictive analysis. And look at the technologies. If you can make some students of yours practice this, one of them, why he will not get a job? Everybody is going for for a software or IT job, IT enabled system. See, what is the big idea in there is some mall in somewhere in the world, and that is what working. That fellow sends say TCS or Cognizant or anything, that fellow sends it here. This fellow sits for 1 or 2 hours after all his WhatsApp messages and birthday parties, etc., and solves that actually, and then tells and makes that fellow work, and that's all it is. Mall is okay, done. Then what he will do? My project is over, and he will have the team will give a party. He'll have pizza all over the place and enjoy. That's all. That's not a growth for the individual. After 2 years, he will get tired of that. When you get into the engineering, it's always a bliss here. It's always a bliss. You will be always happy. You will never be sad if you are in engineering. If you are in services of that type, actually, where your engineering is not at all used, you will get tired. You will get tired. Of course, good money you will get. See, because I always say that actually the core engineering job is like a diode curve. The IT-enabled services or IT job is like a transistor curve. Yeah, you will get initially good current. Afterwards, you will get saturated. Unless otherwise you increase the what is it called, the base current, you cannot get a collector current at all. You will not get a collector current at all. I'm talking about the old bipolar. Same thing is good for the, if you don't change the gate, you will not get the drain current. Actually, so these are all something which is happening. So try to make your students to adopt or you try to move them to core engineering industry. Country will benefit, he will benefit. See, today core engineering is something which is really growing in a big way. I want you to always look at that. Okay. I just put one, this is taken from one paper which is given by, this fellow has got a doctorate on that. So you have taught networking most of the people, topology, architecture, and platform. These are all the 3 things which is there. So he has only defined that physical configuration, software organization, etc. So you should know, because the IoT works basically on a communication, distributed communication. And if the fellow doesn't understand properly the topology and architecture, he cannot build a system. Okay. And IoT network platform, this is actually another thing which is there. So what is the basic thing? I'll go with this human-machine interface. One fellow enters the hospital or anything like that, this IoT which is there. These are all IoT. Okay, this is IoT, etc. Okay, and computer-aided design, virtually all these things are taken from the human being. So that is being shared in the multi-optimization actually. Okay, that's actually done. Then what is the next one? The design information, etc. is all available. So you need a person to move as a healthy person from a patient, and all these things have to work together. That is the advantage of see, when you are going to have various things and various types of objects which are going to talk in multiple languages, multiple protocols. I'm talking about NFC, National LoRa, long ranging system, or actually the Wi-Fi, Bluetooth, Zigbee, all those things actually, there should be a gateway. And my contribution is gateway. I am developing a full-fledged multi-protocol wireless gateway, and I'm doing it actually really great. Okay, that's what I'm doing. So you can buy anything from anybody. My gateway will take care of it. That's actually how I'm trying to build it. Okay, healthcare services. These are all something which is supposed to be there. IoT in health. You have that security is a major problem in IoT because of the simple reason everything is exposed. So it is actually major. If any of you want to get into IoT, it is actually easier for you to get into security and create a model for a typical application like healthcare or actually home automation, etc., and try to prove it with a practical implementation. You will get a PhD and you will get probably a good job also, practical job. Okay, and this is what we built actually. We built once upon a time actually. We took a 32-bit MCU microcontroller, and these are all actually the power. Okay, power. Okay, solar panel. Okay, All these things. Solar panel taken from a Hyderabad company only. And I am also looking at actually the other company which is in Coimbatore, that's also there. And BHEL is also producing that. So these are all the sensors which are there. And this is a microcontroller. Of course, sensors means there is positively a signal conditioner built inside. And this is a communication Zigbee. I am now converting in this particular Zigbee as to three, some in Zigbee, some in what is it called, Wi-Fi, some in actually the Bluetooth, so that it will work together. And I want everybody to work with this. Actually, this is a beautiful thing which is we actually are doing. This is actually the way in which there's a concept which this is actually done by the VIT, along with the VIT students I did. We did something on energy harvesting, okay, energy harvesting. That means when I am walking, there is an energy generated. That energy should be converted. Sorry, there is a physical energy which is generated, and I should be able to convert that into a electrical energy, and that should be going to the battery or make some systems to work with that particular battery. That is true for a car which is running actually. While running actually generates energy, and that energy should be converted into electrical energy, and battery should be stored. Battery should be charged. These are all something which we did, and really speaking, actually, I didn't get the proper result in this, so I just left it. Actually, student got, of course, PhD in this, and they went through. Okay, this is IoT remote health monitoring system, and okay, now I want to. This is actually, don't say that, Jayaraman, you don't try to sermonize. I will not sermonize. I will not advise. I am only suggest. Hey, this, if you follow this, you will be, that is actually like a famous Hindu philosophy, dharmam chara. Doesn't mean that you have to do it. If you do it, you are happy and the people are happy. Society is happy. That's how it is. Okay. So I always say that actually the lab, to assess how much one has understood. That's all. Lab should not bother about whether the result has come or not. Has he understood? See, I have seen at least in some of the state-aided colleges, which is actually failing students in the lab. If the fellow has been good, 9 out of 10, they have given in the record 9 out of 10 in almost all the sessions. The last session, because that output didn't come, they have failed him. It's not possible. So you only say how much he has assessed. Based on the understanding, you try to give marks. Answers must be brief and to the point. Don't allow them to write English in big sentences. One thing, you will not understand what he has written because he is not a British or an American write a chaste English. You are not a great English literature fellow. So you let him write in bulleted points, graphs, etc. So you at least understand that. Okay. Because today's actually, I feel pity for some of the faculty because the evaluation of the answer books of some of the students, I tell you, you will feel why I have done, what sin I have done in the last Janma to get this particular paper in front of me, which I don't understand head and tail of it. So tick it and give. That is why in places like Anna University, they pass student without any examination also. Because exam paper correction is a very difficult one, They take advantage of this corona and pass people without any examination. Excellent. Okay. That fellow is a corona degree holder. Corona degree holder means he has not been evaluated. Okay. Corona. They're all called corona degree holders. And 10 fellows came to me for this one. I have kept a test out of which none have passed in my test. Okay. That's how it is. Long winding English prose, we are not capable. No, actually another one is actually, if there is a question, if there is a problem or it's a challenge, there is no unique answer. Everybody can think differently and come out with an answer. Okay. So you should look at how they are thinking, that we should improve the thinking. Mostly it will be design oriented. That's all. Problem should be design. It is expected that learners should be innovative. Yeah, they should think at least one as, instead of everybody putting 741, let him put 1554 or whatever it is, another IC, and try to say that this is better than this because of this facility. I will give mark for them. Okay. Approach should be analyzed, not the result. Purpose is to learn. See how much one has learned. What can be done to improve ongoing process. This is what I want every student to undergo in every every lab session. I don't want to say experimentation because we don't do experimentation. We are doing exercise, and in that exercise. So if you really do it actually, and it's basically a integrated hardware platform, you can do everything in that. Such model. So significant challenges we face cannot be solved at the same level of thinking we were when we created them. Einstein is saying. I'm sure some more people would have told the same thing, but really speaking. So I have created a problem. And what, say for instance, as per the independence of India, say for instance, Jawaharlal Nehru or any of those prime ministers would have done something. Okay, I don't want to say that they did with any bad intentions or anything. That probably in 2021, it may not be relevant. So we cannot use the same logic and try to solve it in 2021. Probably you have to come out with a new logic and try to solve it. This all the things. Okay, so that is actually system thinking. I am again telling you, unless you make students to think system-wise, you will not be able to become a competitive person. Okay, competent person. Future is ours. Please understand, India is going to be a great country in the days to come. I believe in 75. I'm sure you should believe in 35 or 40, and somebody else will believe in 20 or 22. Okay. And I am ready to answer any question you want. And if you have a capability, you send me the question and then I will answer it. And my mail ID is available to you, and you can positively keep in touch with me for any support. Please understand, any support in your academic session. With that, I close my talk for today, and I am ready for further interaction if you have any. Thank you so much, Nagarjuna College of Engineering and Technology. I enjoyed the session.
Thank you, sir.
Yeah.
Hello, sir.
Thank you. Thank you very much, sir. Jairam
Nice
sir.
to be, sir. Actually, one advantage I have doing it in this around 1 o'clock session, because of the simple reason, no questions will come, everybody is after this lunch. Why should they ask me a question and waste that time?
Yeah.
Okay, sir. Okay, everything is fine, sir. Excellent, sir. And move away.
No, our participants will have their own queries, sir. I think 1 or 2 will ask questions, I hope.
Sure.
Any questions from participants? Hopefully the session was very nice. I think many people are sending message, nice presentation, nice session, sir. So like that. So any questions? Any questions from audience? Hello?
I'm here.
Yeah.
Participants, any questions, you can also let us know in the chat section. Rohit, sir, shall we wind up?
Yes, I think no questions. We can wind up. Yeah.
Thank you, sir, for sharing your knowledge and giving us an insight to automation engineering through graphical system design. Your depth of understanding and ability to present the subject in such an interesting way is really commendable. We look forward to your next session, which is scheduled on Saturday. Thank you again, sir.
Oh, not Saturday, Monday.
Monday.
Don't
Thank
put
you,
me on Saturday.
Sir, 1 minute. Sorry. One more question. I think Tanveer Bag. So he's asking how to improve communication in area where there is no network.
How to improve communication in an area where there is no network?
Yes. That is a question.
See, this question is a little difficult for a person like me to answer, because in network, if it is not there, I don't know how to communicate. The only way is actually through the satellite. Okay, that is, I'm talking about. I don't assume satellite as a network the way in which it is being understood. So satellite. So what you have to do, have a dish with a transmitter receiver at your end, like most of the people who are in the amateur radio, they have a communication system in an in-communication area. That means what? In a place where there is no communication facility, infrastructure. That is why we have actually ad hoc network and infrastructure-based network in typical communication. So ad hoc network is the only way, and ad hoc network is only, you can develop your own ad hoc network. That means you bring certain things, and through the satellite you communicate. Okay, that's what they were doing in an inaccessible area using satellite. Of course, this is what I know. But if he's looking for some other answer, I don't know what is the answer I can give.
Sir, he continues to ask, example, if in forest we do not get network and we are not able to get the data on time, so the application of IoT fails.
IoT, yeah, what you say is correct actually. So what is the basic thing is actually in a typical forest area, or actually say for instance in a disaster area, there are two areas which are actually communication gets breakdown. And what is the basic thing they do is actually they establish a network using an ad hoc technique and then use satellite only. Okay, so even in the IoT, so the various trees can talk to each other, then beam it in some, there are more trees are being cut, So at that time, actually, you can try to take it to the satellite and do it. That satellite is the only way you can do it, according to me. With this knowledge level I have.
So there is another question. Suggest some guidelines. Those are beginners for the lab view. They want to study the lab view. Some students want to participate. So she needs some suggestions on for the beginners.
See, LabVIEW is like I don't know how many of you know. It's like a ladder, or we call in Kannada sautu. Okay, it's like a sautu. Okay, LabVIEW itself is not the solution. It is actually the understanding the problem is more important. See, for instance, if you really open the NI and you will see hundreds of data acquisition cards, which one should be used? So you should know sampling theorem very well, and you should know what is the so unless and otherwise you understand the application in detail and then try to go about understanding. LabVIEW is very similar to any other programming language. Okay, so the LabVIEW, what is the advantage is graphical, so you will be able to do it. Wow, okay. Now what is the procedure you have to do is actually the LabVIEW have got, sorry, National Instruments have got a website where there is supposed to be the lab basics 1, basics 2, like that. Okay, so you can do it. Actually, there is a better people who will be with you, like Manimaran or Sunil. They will be able to talk much better, much more objective to your particular problem of how to start with the LabVIEW. Actually, I'll tell you, LabVIEW is one of the easiest programming language. Please don't think that I am an expert. I am not. LabVIEW, I am not a LabVIEW expert. Okay, and Manimaran and Sunil will be able to throw more ideas because they have learned afresh and they know how to. Actually, they have also created a lot of certified LabVIEW developers actually, so they know better.
Yes, sir. Thank you, sir. Participants, any other questions? Yes. Yes. With this, we can wind up the session. I thank all the participants for joining this session. Please kindly note you can join back at 2 p.m. for the session 3. Thank you all. Thank you, sir.
Thank you. Thank you. Have a good day. May God bless you all. Thank you.